This property is essential in order to obtain a good result. Ideally, the cleaning agent should be the same refrigerant used in the system, since it is miscible and soluble with the oils used to lubricate the compressors. The system first tries to introduce refrigerant at high pressure through the highest point of the refrigerating's installation and, when being removed, after filling to the siphons and the spillways, the cleaning agent is able to remove the oil with which it is miscible. Nevertheless, there are several reasons why a single refrigerant is generally used for system cleaning, regardless of whether the one used in the installation could be used. When a system has lost its refrigerant through a leak, we will not be able to use that refrigerant for cleaning the system. If the circuit has a lower than necessary refrigerant charge, it is possible that the installation, even without a leak, does not have enough refrigerant to exit the installation through its lowest connection in liquid phase. Of the three levels of pressure, medium, high and very high, high pressure is better suited to this task. For this reason, it is better to use high-pressure products such as R22, R407C and R404A, in preference to R134A or R410A. Among the high-pressure gases, R22 refrigerant contains chlorine, very effective at removing certain unwanted impurities. In any case, R22 is one of the cheapest refrigerants available. Therefore, the most suitable product for cleaning will be R22. In countries in where it is not available or its use is prohibited by law, another refrigerant of the same pressure such as R404A, R407C or R507 can be used. It is possible that in certain cases, even if R22 is available, it may be more practical to use another product for cleaning. Let us consider this example. Let us imagine that we have to clean an installation with 300 kilos of HFC R507. If we use the same refrigerant for cleaning, at the end of this process we will be able to recover the coolant to allow the operation of the equipment. Of course, it will have been necessary to replace the dryers and POE oil. Please keep in mind that the moving parts of the compressors will be dry, so recommissioning will have to be carried out progressively, otherwise we could break the compressor. The density's decantation is the most important physical principle that the refrigeration and air conditioning professional must understand to be successful at this task. Refrigerant is heavier than the water and oil, so that when introduced into a system it goes underneath the fluids with a lower density. Through the series of overflows, these substances are pushed with the refrigerant out of the system. The point where we introduce the refrigerant from the refrigerant bottle must be the highest of the refrigeration circuit. The cleaning refrigerant will enter the circuit having lifted the lower density substances. As this mixture arrives at the overflows, some of the products we are trying to remove will go to the next siphon and so on until the end, where we will have positioned the pressure switch that is connected to the main component of the system. Once this operation is finished, the installation will have drawn sufficient refrigerant until the pressure of the refrigerant bottle and the circuit are equalized. When the pressure is balanced, the low part of some or even all of the siphons will be full of liquid refrigerant. Sitting on top of the refrigerant will be the lower density substances that we are trying to extract. The cleaning refrigerant will then enter at a significant pressure differential, causing it to drag the remaining oil from the tube and component inside surfaces, or walls. Once the system pressure is balanced, we can connect the Fri3Oil system to the circuit to be cleaned and, through cycles of injection and suction, push the cleaning refrigerant through the circuit until it arrives at the Fri3Oil unit in a liquid state. This will tell us that all the siphons of the refrigerating circuit are full of liquid refrigerant and that the lower density products are on top of the refrigerant and at the spillways. If the liquid injection is then cut and the refrigerant is recovered, the lower density products will again pass through the spillways until they are below their level. We will then only have vapour in the system. In order to perform a new cycle, we will once again have to inject liquid refrigerant. As before, the substances again pass up and down the spillways. Once we finish recovering the liquid refrigerant and we can only see vapour through the sight glass, it will be necessary to inject from the refrigerant bottle again, in a controlled way, until we can again see liquid through the sight glass. This cycle will have to be repeated until there is no foam in the product passing up and down the spillways, either in liquid or vapour phase. Only then can we be sure of having solved the cleaning problem. In the system, there is a control sight glass that lets us know when refrigerant arrives in its different phases, liquid or vapour, and when foam arrives, which is produced by the substances being extracted. Once we do not see any foam passing up and down the spillways at the control sight glass, it will mean that the entire circuit is clean. Where the required quantity of refrigerant is greater than the 60 kilos of the refrigerant bottle, it will be necessary to divide the circuit to be cleaned into smaller sections. However, it is useful to know that a 60 kilo bottle is enough to clean a system up to 50 horsepower. An extra refrigerant bottle can be used if we notice that the amount is not enough once the process has been initiated. However, this refrigerant transfer is not recommended, and the situation will have to be corrected before carrying out the next system cleaning. When we cannot be sure that the cleaning refrigerant has passed through all the walls of the circuit, we will have to flood the container before starting the cleaning process to ensure the separation of substances of different density will take place. Later, the injection and suction cycles must be carried out from the highest part of the equipment. For these situations, the use of pumps is recommended to help with the filling of the container before cleaning the equipment. These pumps can transfer 1000 kilos an hour compared to little more than 100 kilos an hour achieved using the system's transfer function alone. This principle is used by all refrigerant recycling systems. As the refrigerant arrives in the cleaning system, an expansion valve converts it into an expanded liquid. This is taken to an evaporator that changes its phase, whereas the liquids, such as oil, acid or water, are deposited in a trap or liquid separator. The refrigerant and vapour phase is taken by the compressor of the main machine. It condenses and returns to the bottle in a cooled liquid phase. This will cause a pressure differential for the new cycle of cleaning greater than in the first injection. The pressure differential between the injection from the refrigerant bottle and the suction of the compressor of the main machine creates a turbulent state. thus helping the removal of products from the interior of the circuit. The miscibility of acids with the oil in the internal circuit means that acids are extracted when the oil is removed. Furthermore, many solid particles created from the breakdown of the oil will be drawn out with it, and others are drawn out as a result of the pressure differentials. These particles will also draw out any water, which is not miscible with either the refrigerant or the oil. For greater effectiveness of the cleaning system, the condenser fans must be stopped when carrying out the injections. In this way, the pressure differential between the injection and the suction will be further increased. This is very important, otherwise the cleaning time will be almost doubled and will diminish the effectiveness of the system. Increasing the refrigerant bottle condensing temperature and pressure while liquid is arriving in the Fri3Oil system will also improve the overall operation of the system.